Hello and welcome to Mr. Tompkins EdTech and my series of walkthroughs for the AQA GCSE Mathematics past papers. This particular paper is AQA June 2019, Paper 1, Foundation Tier. Now, with the new specification being new, Grade 9 to 1 past papers are like gold dust and you should not be watching this video unless you've already attempted the paper yourself under test-like conditions. If you haven't, stop the video now and go and do it first. I'm serious, go. Still watching? That's great. Why not subscribe to my channel so you can easily find it again the next time you want some help with your maths. I have plenty of A-level content too, so make sure you come back and check that out if you're carrying on with your maths next year. Please hit the like button if you found the walkthrough helpful. This really helps out my channel and it makes it much easier for others to wade through all the YouTube dross and find the good stuff. Also, before attempting the actual past papers, make sure you've gone through all the practice sets first. AQA produced 4 sets of practice papers to help students prepare for the new GCSE exams, and I would advise you to work through these before moving on to the actual past papers. Have a look at this video series which gives full walkthroughs for AQA practice sets 1 to 4. If you don't happen to have a copy yourself, you'll find a download link to the practice paper in the description below each video. Finally, feel free to ask questions below. It would be helpful if you include a question number and be as specific as possible. I really appreciate your comments and feedback and I try to respond to these as quickly as I can, especially around exam times. Okay, let's get into it. Welcome along to another AQA past paper walkthrough. Today we're looking at GCSE Mathematics Foundation Tier Paper 1. And it's the June 2019 series, although you can see this one actually went out in May of 2019. Okay, let's get cracking. Question 1. Which type of angle is the largest? Circle your answer. Okay, so we've got right, reflex, obtuse, acute. So right angle is one of those, isn't it? It's 90 degrees. Reflex is any angle beyond a straight line, so an angle like that. Obtuse means an angle between 90 and 180, so between a right angle and a straight line, and an acute angle is less than a right angle. Okay, so the one that is the largest type is this one here, isn't it? It's the reflex angle. So I'm going to circle that one there. Question 2. Solve 4x equals 8. Circle your answer. Okay, well, if 4x is equal to 8, then we can divide both sides by 4, can't we, to get x by itself. So 4x divided by 4 is x, and 8 divided by 4 is 2. So my answer is this one. X is equal to 2. Question 3. Work out 10 plus negative 4. Add in a negative is the same thing as taking away. So 10 plus negative 4. These two symbols here you can make into one minus sign. So I can rewrite those as 10 minus 4, and 10 minus 4 is 6. So it's that one. Question 4. Circle the calculation which works out half of 12. Okay, so 12 divided by 0.5 or 12 divided by half is not finding half of 12. 2 divided by 12, that's the wrong way around. 12 times a half, that is working out a half of 12. 12 divided by 50 times by 100, that's the wrong way around, so that's not one either. It's just 12 times 1/2. Question 5a, work out 364.5 plus 17.9 minus 2.08. So I've got decimal addition and subtraction here. I'm gonna start by just adding these two numbers together first. And then I'm going to make a total, and then I'm going to subtract that part second. Okay, so first off I'm going to add 364.5 to 17.9. I'm going to do column addition. When you're adding numbers, just make sure that you line them up correctly. So the decimal point needs to be in the same place. So you can see I've got one decimal point under the other. And if you do that, it should be a good job. So 5 plus 9 is 14, so that's 4 carry 1. 4 plus 7 is 11 plus 1 is 12, so that's 2 carry 1. and 6 plus 1 is 7, plus that extra 1 is 8. And then I've got 3 with nothing, so that's 382. And the decimal point is in the same place, 382.4. Okay, so I've got 382.4 so far by adding those two numbers together. Next, I need to subtract the 2.08. Now again, with subtraction, just need to make sure I line up the decimal points correctly. So the decimal point of my subtraction should be there. So now I've got 2.08 to subtract. Now notice I haven't got a number above the 8, so I can just fill in an extra 0 there, just so that I've got the same number of digits. Should make it a little bit easier to do the calculation. So first off, I've got 0 subtract 8. Now I can't take 8 away from 0, so I'm going to have to borrow 1 from the 4, which makes 3, and add 1, or add 10 to my 0 to make 10. Now I can do 10 subtract 8, which is 2. 3 subtract 0, 3. 2 subtract 2, 0. 8 subtract nothing is 8. 3 subtract nothing is 3. And the decimal point stays where it is. So my answer is 380.32. 380.32. Question 5b, work out 9.36 times 2. I like to do Napier's Bones method for multiplying. So you have little squares like that, as many squares along as you have digits, and as many squares down as you have digits like that. So, and the decimal point was there, wasn't it? So 9.36 times 2. 9 times 2 is 18, so I can write 1 there and 8 there. 3 times 2 is 6, 0 there, 6 there. 6 times 2 is 12, 1 there, 2 there. And then with Napier's Bones method, you add up along the diagonals. So the first diagonal has a 2 in it. The second diagonal has got a 1 and a 6, which makes 7. Third diagonal has got an 8 and a 0, which makes 8. And the last diagonal has got a 1 in it, which makes 1. And then I just read the number around like this. So the answer is, well, the digits are 1872. But my question had 2 digits behind the decimal point, so I'm going to have 2 digits behind the decimal point as well in my answer. So it's going to be 18.72. Just also, you could just round that off to 9, and 9 times 2 is 18, so just making sure you've got the right degree of your answer is a good idea before you move on. Okay, but we're done. 18.7. Question 6. 5 points are plotted on a centimetre grid, and you can see them here. Look, what does it say? The points of 5 of the vertices of a hexagon. Each side of the hexagon is the same length. Work out one possible pair of the coordinates of the other vertex. Okay, let's just put it on the page so you can see all 5 points that have been drawn. I'm just going to highlight where the hexagon, or the part of the hexagon, is that I should be able to see already. So it goes like that, round there, and along there. Okay, now there are actually 2 places I can put the last point. Now we're told that each side of the hexagon is the same length, and you can see along the top here is actually length 5, isn't it? 1, 2, 3, 4, 5 units along. And actually, so are the diagonal ones as well, because if I use Pythagoras' theorem, you can see I've got 3 units in this direction and 4 units in this direction, and 3 squared plus 4 squared is 9 plus 16, which is 25, and the root of 25 is 5. So that one there is also, the hypotenuse is also 5. Okay, so drawing my last corner on, I need to go, well, I can either go 3 units this way and 4 units up, which takes me to that point there, and that then would be my hexagon. What coordinates is that? That's 2 along, 5 up, so that's corner 2, 5. Actually, you could also put your 5th point here, because whilst it says that all the sides are the same, it doesn't say it's a regular hexagon, so you could have actually had your hexagon looking like that. That is still a hexagon. So I could have also had the point, what's that? 8,5. I could have had the point 8,5 as well. That's a possibility. But I don't think many people would go for that one. I think actually most people would, it would make more sense to draw it there. So I'm going to put in the coordinate 2, 5. 2, 5. Question 7. Amy and Brad each have some money. Carly has no money. Amy gives £7 to Carly. Brad gives £5 to Carly. They all have the same amount of money. How much money did Amy have to begin with? Okay. Now, let's just imagine this is the amount of money that Amy had. Okay, and then this is the amount of money that Brad has. Okay, so I'm going to take some of Amy's money, let's say this amount, which was £7, and I'm going to give that part to Carly. And I'm going to take some of Brad's money, which was £5, and I'm going to give that to Carly. So then this is how much money then that Carly gets. So Carly is going to get £7 from Amy and £5 from Brad, making £12 altogether. Okay, so they now have £12 left each. So that means what's left in Amy's money is 12, so that must be 12 there. And what's left in Brad's money is 12, so that must be 12 there. So how much money did Amy have to begin with? Well, it's that money we said that Amy had to begin with, that amount there. So the 12 and the 7 together, which makes 19, doesn't it? So what did Amy have to start with? She had £19. Question 8. A game is played 50 times. The vertical line chart shows the winning scores. Okay, so I've got the number of games up the side there and the winning scores along the bottom. Okay, so it says, part A says write down the mode. Now mode means most, doesn't it? So which score occurred the most? We can tell which score occurred the most because it's going to be the tallest bar on our bar graph. And the tallest bar is this one here. Okay, so the mode is not 14. The mode is 29. Okay, 29 is the winning score that occurred most often. It occurred 14 times, which is more than any other score. So the modal score then is going to be 29. Okay, now we're told the game is played again. Use the chart to estimate the probability that the winning score is 25. Okay, well, probability is equal to successful outcomes. In this case, that will be the number of times 25 is scored, divided by total outcomes, which is how many times the game was played altogether. Okay, so if we come up and look at our graph here, we can see that the number of times that 25 won was 4 times. And we know that the game was played 50 times altogether. Okay, so our probability then, our successful outcomes is going to be the 4, and our total outcomes is going to be the 50. So then the probability is going to be 4 out of 50. Now that cancels down, but actually you don't ever get any extra credit for cancelling down probability questions, so I'm just going to leave it as 4/50ths. Then part C says use the chart to estimate the probability that the winning score is 27 or more. Okay, so going back to our graph up here then, 27 or more is going to be, well, it's going to be the 27 bar, which has got 8 in it, and our 28 bar, which has got 10 in it. So 8, 10, the 29 bar that's got 14 in it, and the 30 bar, which has got, it's halfway between 6 and 7, isn't it? So that's 7. Okay, so how many outcomes are successful here then? It's going to be 8, 10, 14, and 7. What does that add up to? 8, 12, 9. And 1, 1, and our extra 1 is a 3. So that makes, so our answer is 39 out of 50. Question 9. Write down all the factors of 18. Now I tend to do my factors like this in factor pairs. So, well, you've always got 1 that goes into your answer and 18. And then I step up from 1. Is it, let's try 2. Does 2 go into 18? Yes, it does. It goes in 9 times. Does 3 go into 18? Yep, it does. It goes in 6 times. Does 4 go in? No. Does 5 go in? No. And you can see I've met myself come back down the other way now, because the only numbers between 3 and 6 are 4 and 5, and I tried both of those and they weren't any good. So now I've found all the factors and I know I haven't missed any out. So 1 and 18, 2 and 9, and 3 and 6 are going to be my 6 factors of 18. Okay, next one. Work out the lowest common multiple LCM of 12 and 15. Many students get LCMs and HCFs mixed up. So we want the smallest number that is a multiple of both 12 and 15. The multiples of 12 are the numbers in the 12 times table, like 12, 24, 36, 48, 60, 72, and so on. Just write down the first few multiples of 12 and then switch over to the other one, 15. 15, 2 15s are 30, then 45, and then 60. Now, as soon as you get a number which is the same in both lists, that has to be a common multiple. And that was the smallest number in both lists, wasn't it? So that is our lowest common multiple. So here the LCM is 60. Okay. Question 10. Coaches take people to a festival. Each coach can take 50 people. From one city there are 820 people. How many coaches are needed? Okay, so a coach can take 50 people. So 2 coaches can take 50 and 50, which is 100 people. Now we want 820. So we're going to have at least 8 lots of 2 coaches, aren't we? So if I have 8 lots of 2 coaches, that's 16 coaches. That is enough for 800 people. So 800 is 8 times 2, which is 16. But I've got 820 people, so I still need to put 20 people somewhere. So I'm going to have one more coach, aren't I? So that extra 20 people is going to be one more coach, meaning that I've got 17 coaches altogether. Okay, so I'm going to have 17 coaches. Part B says, from a different city, 13 coaches are needed. Each coach costs £450 to hire. Work out the total cost of hiring 13 coaches. Okay. Now I'm going to use Napier's bones for this calculation. Now, if you know how to use column multiplication, you're good at it and you can always get the right answer, fine, just stick with that. But if you're one of these people who's multiplying sometimes comes out right and sometimes doesn't, then perhaps you want to think about switching method. Maybe give this one a go and see if you can do it any more reliably. So what you need to do with Napier's bones is you have as many columns and rows as you have digits that you want to multiply together. So I've got 4 columns because I've got 450 to multiply, and I've got 2 rows because I've got 13 to multiply. Now in the first box I'm going to write the result I get when I multiply 4 and 1. So 4 times 1 is 4, so that's 0 tens, and 4 units. 5 times 1 is 5, so that's 0, tens, and 5 units. 0 times 1 is 0, so that's 0, 0. 0 times 3 is 0, 0, 0. 5 times 3 is 15, so that's 1 there, 5 there. And 4 times 3 is 12, so that's 1 there and 2 there. And then with Napier's bones, I add up along the diagonals. So I've got 1, 2, 3, 4, 5 diagonals to add up along. So the first diagonal adds up to 0. The second one's got 0, 0, and 5 in it, which is 5. The third one's got 0, 5, 1, and 3. So that's a 2, isn't it? So 2, 3, 8 adds up to 8. And then on this diagonal I've got 0, 4, and 1, which adds up to 5, and that one's empty. So the answer then you can read around like this. It's 5850. So that's going to be £5,850. Question 11. Here is a triangle on a square dotted grid. Now I'm just going to write down the dimensions of this because I want to just double check I've got them right. So there's 2 squares or 2 gaps that way and 3 gaps going up that way then, isn't it? So it's a 2 by 3 triangle. On the grid below, show how you can make a parallelogram with 2 of these triangles. Okay, well I can make a parallelogram out of 2 triangles by taking one triangle like that and another one and just flipping it around. So I've got one like that, haven't I? Okay, so it's a good idea just maybe do a little sketch on the left before you start on your dotted paper, because otherwise you might be in danger of making a bit of a mess of it. Okay, so I'm going to draw my triangle here and then up to there and then down to there. And then the other triangle next to it. Like so. Okay, so there's my 2 triangles formed into a parallelogram. Okay, what's next? On the grid below, show how you can make a trapezium with 3 of these triangles. Okay, so I think what I'm going to do with this one then is push 2 of the triangles together to make a rectangle first, and then if I then add another triangle on the end, look, then that's a trapezium. It's got 2 parallel sides. Yeah, that's what a trapezium is. Okay, so that's what I'm going to do here. I'm going to make so let's add those in then. So I'm going to have 2 triangles, so that's 1 triangle, 2 triangles along there. Okay, so this is going to be my rectangle made out of my 2 triangles. And then divide that rectangle up into the 2 triangles that make it up. And then I can add that extra triangle on the end. Okay, and there's my trapezium. 2 parallel sides makes a trapezium. Okay, last one. On the grid below, show how you can make a rhombus with 4 of these triangles. Okay, so a rhombus is a diamond shape, isn't it? And I could make a diamond shape by pushing 2 triangles together like that and then doing the same thing kind of underneath. Okay, and then I'm going to get that side is going to be the same as that side, it's going to be the same as that, it's going to be the same as that. So that will give me my rhombus then, won't it? Okay, so again, I'm going to start drawing that shape on. So maybe start here. Maybe I'll start with the X shape in the middle. That's probably the easiest thing to do. So that's going to have like 3 units, 3 units. So 1, 2, 3, and then 1, 2, 3 down there. And that's going to be 2 units and 2 units, isn't it, that way? So 2 and 2, and then I can just join up all the corners around the edge now to make my rhombus. Okay, and there's my shape with 4 equal sides, making a diamond or a rhombus. Okay, job done. Question 12, work out 65% of 300. Okay, now this is the non-calculated paper, so this is a non-calculator approach for finding percentages. I start with 100%, that's everything, and that's going to be my full amount, which is 300. Okay, and then what we're going to do is we're going to make 65% out of handy building blocks that we can easily find. So if I take 100% and halve it, I'm going to get 50%. So half of 300 is 150. If I take 100% and divide it by 10, I'll get 10%. 300 divided by 10 is 30. And if I take 10% and halve it, I'm going to get 5%. Half of 30, half of 10% is 5%, so half of 30 is 15. Okay, now 50, 10, and 5 together. So 50 plus 10 plus 5 is 65, isn't it? Okay, so we're going to do the same thing on the other side. We're going to take these 3 values, add them together, and that should give me 65. So 0, 0, and 5 is 5. 5, 3, and 1 adds up to 9, and I've got 1 on the end, so 195 is my answer. 195. Question 13. In a game, the average score was 50. Tom's score was 5 halves of the average. Circle Tom's score. So in other words, we're taking 50 and we're multiplying it by 5 over 2, 5 halves. So when we do that, we have to first divide by this new denominator. So 50 divided by 2 is 25. And then we multiply by that top number. 25 times 5 is 125. So it's that one there. Question 14. Here is a cuboid. Work out its volume. So the volume of a cuboid is just length times width times height. So my length is 7, my width is 5, and my height is 10. So just need to multiply those numbers together. 7 times 5 times 10. Now 7 times 5 is 35, and 35 times 10 is 350. So my answer is going to be 350 cubic centimeters. Question 15. Circle the shape that has a uniform cross-section. Okay, so a uniform cross-section means it's got the same shape on its front face as it has on its back face, and if you sliced it up any point in between, you'd get that same cross-section appearing. Okay, any shape with a uniform cross-section is a prism. Now what does a cone look like? Cone looks like that, doesn't it? So if you slice this up, you'd get a circle each time, but you would get a smaller and smaller circle depending on how far along the line that you crossed. So it's not a cone. A sphere, it's like a ball, isn't it? Okay, if you slice a ball up, you're going to get, again, you're going to get a circle, I suppose, but you're going to get different size circles depending on where you slice. So that one is not a, it doesn't have a uniform cross-section. Now a cylinder looks like that, doesn't it? Now it's got a front face that looks like this. It's got a back face that also looks like this. Looks like a circle, and if you slice it any point in between, you'll get another face that matches the front and the back. So a cylinder does have a uniform cross-section. What about pyramid? So I'm doing a square base pyramid here. But if you slice this up, it's not going to have a uniform cross-section. It's going to look different every time you slice it. Okay, so the only one that has a uniform cross-section is the cylinder. and a cylinder is a circular prism. So yeah, it's that one. Question 16a. Here is a map showing points A and B. Kamal wants to measure the bearing of A from B. He draws two lines and measures the angle between them. Okay. Kamal says the bearing of A from B is 100 degrees. Is his method correct? Give your answer. Okay. Well, the bearing of this point down here, B, from this one is 100 degrees because we always give it clockwise from north. But that is not the bearing of A from B. That's the bearing of B from A. We are leaving A and we are going to B in this direction. Okay, and that's not what we were asked for. We were asked for the bearing of A from B. So you need to leave B and go towards A. So we found the direction coming back the other end. Now, if I want to do the bearing of A from B, what I should have done is draw a north line on B to start with, not on A. So I should have drawn a vertical line coming up from B. That's my north line. And then my line between A and B like that, I would need to measure clockwise from north. So I'd have to measure this angle around here. And obviously, unless you've got a circular protractor, that's going to be impossible. More likely what you do is you kind of measure this one, you take it away from 360, and that will tell you what's left. And that's how you would probably do that one. But what's he done wrong? So I'm going to say not correct. Kamal has found the bearing of B from A and not A from B. 16b. On a different map, the bearing of D from C is 45 degrees. Nina says D is northwest of C. Is Nina correct? Okay, so let's just think about that bearing first. The bearing of D from C is 45 degrees. So if we have the point C and we draw a north line coming up from C, then the bearing of 045 degrees is a 45 degree angle taken from that north line. Now 45 degrees is half a right angle, so you can see on my ruler it's saying 45 degrees, isn't that? And it's in that direction there, isn't it? Okay, so then D is going to be somewhere up here. Okay, now what direction is that from C? Is that northwest? I don't think so. Do you remember your kind of direction bearing? So north is always at the top, and then it's never eat shredded wheat or news if you're boring. Oh no, it doesn't spell news, does it? Never eat shredded wheat around the edge, north, east, south and west. So then this direction going off towards D then is halfway between north and east. So that is northeast, it's not northwest. So my answer is going to be never eat shredded wheat, but also Nina is incorrect, as D is northeast from C. Okay. Right, and then finally, it says here that the map shows an airport E on an island. Scale 1 centimetre represents 100 kilometres. And it says here that a plane flies due south from the airport. How far does it fly until it reaches the sea? So we've got north marked on this map. Now again, if I have never eat shredded wheat, then south is downwards, isn't it? Okay, so if I get my ruler out and draw a line going downwards from east, okay, so let me just draw a line. So it's going off in that direction, isn't it, the plane? So how far does it fly until it reaches the sea? It reaches the sea at this point. Okay, where the land ends is where the sea begins. So basically I need to measure that distance then from there down to there. Now, if you're doing a practice paper, then often school reprographics departments produce these papers at a slightly different scale to the original, because they tend to be printed on A4, and your exam paper is not on A4, it's on a slightly different format. So probably if you measure it, you might get a different answer from that in the mark scheme. So, but don't despair, because as I say, it's probably more likely the fact that your reprographics department have reproduced a paper at a slightly different size. But what the mark scheme says, 4.7 centimeters. Okay, now given the scale that 1 centimeter represents 100 kilometers, then for every centimeter I've got there, it's 100 kilometers. So 100 times 4.7 is going to be the distance then, isn't it? 4.7 times 100, which is 470 kilometers. Now the mark scheme will give you a credit for a slightly different reading, so anything from 4.5 up to 4.9 is probably acceptable. Like I say, if you're measuring it with a ruler and saying how can it be 4.7 and it really isn't 4.7, like I say, it might be that the paper's been printed at a slightly different scale, so don't worry too much about it. Okay, but then whatever that measurement is, you can times it by 100 and get the answer, and that is your answer, 470. Question 17a, simplify fully 56 to 24. Okay, so I've got a ratio here that I'm going to simplify down. Now these cancel down just the same way as fractions. Well, I know that 24 is in the 8 times table, 8, 16, 24. And 8 times 7 is 56. So I think I can divide both by 8, can't I? So dividing this side by 8 and dividing this side by 8. 56 divided by 8 gives me 7, and 24 divided by 8 is 3. Can I cancel it down anymore? 7 and 3 are both prime numbers, aren't they? So I'm not going to be able to find a common divisor of those two other than 1. So I know that's my final answer, 7 to 3. Okay, now part B says write the ratio 5 to 4 in the form n to 1. Okay, in other words, I need to take this second number here and make it a 1. Now I can do that by dividing by 4. Now notice 5 doesn't divide by 4. It's not going to give me a whole number answer, but that is what I need to do. If I want to get this number here to be a 1, then I'm going to have to divide by 4. It's the only way that it can be. So what am I going to get? I'm going to get 5 over 4. Okay, now it's perfectly acceptable to leave it like that as a top-heavy fraction. That's what I'm going to do. You could rewrite that as how many times does 4 goes in 5? It goes in once, remainder 1. So you could rewrite that as 1 and 1/4. But I'm just going to leave it like that. It's perfectly acceptable. 5/4 to 1. Bit more ratio fun here. Share £180 in the ratio of 1 to 9. Okay, so if I want to divide 180 into a ratio of 1 to 9, first off I need to know how many parts I've got altogether. So to divide it into 1 part and 9 parts, 1 plus 9 is 10. 1 plus 9 is 10. So there are 10 parts altogether. So take our 180 and divide it by 10. We can then work out what 1 part is worth. So 10s into 180 go 18 times. Okay? And that means then I can take my ratio of 1 to 9 and scale it up by a factor of 18. Okay, so 1 times 18 is easy enough, it's just 18. But what's 9 times 18? Well, 10 times 18 is 180, so 9 times 18 is 180 less 18. So 180, 170, 162. Okay, so 18 to 162. You can just double check here that your two final answers should end up adding up to what you started with. 18 plus 162 is 180. So I'm feeling fairly confident that my correct solution is 18 and 162 pounds. Question 18. Here is some data about the people listening to a radio station one day. And I can see that I've got age 40 and under and age 41 and over. We've got the percentage listening, we've got the mean number of hours listened, and we've got the range of number of hours listening. Okay, compare the data for the people age 40 and under with the people, or the data for the people age 41 and over. Make 3 comparisons. Okay. Well, first off, let's compare like with like. Let's compare these two numbers together. Sorry, the percentage listeners. We can say that, well, the 41 and over is the large percentage by far, isn't it? So we can say that far more listeners are over 41 than age 40 and under. Okay, so more listeners are over 41 or 41 and over than are 40 and under. Next comparison, let's look at the next thing along. The next thing along is mean number of hours listening. And again, age 41 and over have a higher mean. So we can say that on average, listeners aged 41 plus listened longer than those aged 40 and under. Okay, so on average, listeners aged 41 plus listened longer than those aged 40 and under. And then finally, we've got this range here, which tells us about dispersion or spread, how spread out the numbers are. So the range is bigger for age 41 and over again, so that means they are more varied. Okay, so that was, what was it? The range of number of hours listening. Okay, so there was greater variation in the number of hours listened by the listeners aged 41 plus than those under 40. Okay, so there was a greater variation in the number of hours listened by the listeners aged 41 plus than those under 40. Okay, so I've done 3 comparisons, and each comparison I picked a different one of those things here and I talked about them. Now notice that I'm kind of answering in context. I'm trying to talk about what these values mean and not just what the numbers are. Okay, that's quite important when you're comparing. So you have to kind of come back and talk about the actual thing that you're talking about, not just the numbers. Okay, let's move on. Question 19, you're given that 4a minus 2b is equal to 10. Write down the value of 2a minus b. Right, well, if I've got 4a minus 2b is equal to 10, if I divide everything by 2, then I'm going to get 4a divided by 2 is 2a, minus 2b divided by 2 is b, and 10 divided by 2 is 5. So what's the value of 2a minus b? It's 5. Okay. Write down the value of 2b minus 4a. Well, 4a minus 2b is 10. So if you're flipping those around, you're changing the signs on both of them, aren't you? So if I've got 4a minus 2b is equal to 10, now I could achieve that by taking each one of these terms and multiplying it by -1. So that would flip the sign round of everything. So 4a minus 2b would become minus 4a plus 2b, in other words 2b minus 4a. And then 10 times minus 1 would be minus 10. Okay, so we get 2b minus 4a is minus 10. Minus 10. And then finally, you're given that 4a minus 2b is 10 and a plus c is 3. Write down an expression in a, b, and c that is equal to 23. Okay, so I could make 23 by using 2 of this one, because 2 10s are 20, and 1 of this one, because 1 3 is 3, and that would make 23. Okay, so I'm going to use a 4a minus 2b is 10, another 4a minus 2b is 10, and an a plus c is equal to 3, and I'm going to add all of those together. Okay, so 4a, 4a, and a is 9a. I've got minus 2b is minus 4b, and a plus c, which is a plus c, and then I've got 10, 10, and 3, making 23. So 9a minus 4b plus c is equal to 23. Okay, and that's my expression. Can I simplify it? It's already as simple as it's going to get, I think. 9a minus 4b plus c is equal to 23. So I suppose the expression is just that then, isn't it? 9a minus 4b plus c. Right, 0.00097 in standard form. Okay, so it's obviously going to have a negative exponent or power. Now the mantissa part is just the digits written as a number between 1 and 10, aren't they? So I'm going to take my 9 and 7 digits, and I'm going to put the decimal point somewhere so it ends up being a number between 1 and 10. So I'm going to put it here, 9.7. And then I need to multiply it by whatever power of 10 takes me back to the original number. So it's going to be negative because it's smaller than 1, and I've got 1, 2, 3, 4 zeros there. So however many zeros there are, that is the power that you're going to get there. Another way some people think about it is moving the decimal point 1, 2, 3, 4 jumps to the right. That also gives you that 4 there. So either count the zeros, including the one in front of the decimal point, 1, 2, 3, 4, it's going to be power to -4, or count the decimal place jumps. Either way, it's 9.7 times 10 to the -4. Right, what does part B say? Work out 3 times 10 to the 5 divided by 4 times 10 to the 3. Okay, so when you're doing multiplication or division with numbers in standard form, multiply like with like, divide like with like. So let's do the easy bit first. 10 to the 5 times divided by 10 to the 3. Got two numbers with the same base, so we just subtract the indices. So that is going to give me 10 to the power of 5 subtract 3, which is 2. And then 3 divided by 4, that's 3/4, isn't it? That's 0.75. So that's 0.75 times 10 to the 2. So that's 0.75 times 100 then, isn't it? 0.75 times 100, so that is 75. I think it's 75. Anna plays a game with an ordinary fair dice. If she rolls 1, she wins. If she rolls 2 or 3, she loses. And if she rolls 4, 5 or 6, she rolls again. When she has to roll again, if she rolls an odd number, she wins. And if she rolls an even number, she loses. Complete the tree diagram for the 4 missing probabilities. Now, probability is defined to be successful outcomes divided by total outcomes, isn't it? Okay, so what is the probability that she rolls a 1 then? Well, how many successful outcomes there are? There's one 1 on a dice, out of the total outcomes possible. That's 1 in 6. So the probability she gets a 1 is 1 in 6. Probability that she gets a 2 or 3, that's going to be 2 out of 6. And then probability she gets 4, 5, and 6 is going to be 3 out of 6. Okay, so when she rolls again, if she rolls an odd number, she wins. Well, there are 3 odd numbers, 1, 3, and 5. So the probability that it's going to be odd is 3 out of 6. And then the probability that she rolls an even number is also going to be 3 out of 6. Now, I know I can cancel some of these down, but often probability, it's easy to leave them as it is, and you don't get any extra credit anyway for doing so. So anyway, let's fill out our table now, our diagram. So we said that was going to be 1 out of 6 for a 1, or a 2 out of 6 for a 2 or a 3. 4, 5, and 6 is a half. It's already been given. And then my second row, I don't have to do a second row for those first 2. But if we do have to have a second row, it's 3 out of 6 here and 3 out of 6 here. Okay, is that it? Yeah. Oh no, there's more over the page. Is Anna more likely to win or lose? You must work out the probability that she wins. Okay. So winning then is either that she wins on her first roll by going down this route. That's a win. Or if she rolls an odd number on her second roll. So if she goes this way, down here and then up here. Okay. So the probability of win then is going to be that outcome or that route through there. So I'm going to say probability of win is equal to the probability of getting a 1 on the first row plus the probability of getting a 4, 5, or 6 on the first row and odd on the second row, isn't it? Okay. So the probability of rolling a 1, that was just simply 1 out of 6, plus the probability of getting a 4, 5, or 6, that was 3 out of 6, wasn't it? And means times in probability, odd, so that was 3 out of 6 as well. So I've got 1 over 6 plus 3 over 6 times 3 over 6. So 3 over 6 times 3 over 6, that's going to be 9 over 36. Now I need to add 1 over 6 and 9 over 36. I need to kind of find a common denominator. Well, I can actually simplify 9 over 36 to, if I divide top and bottom by 3, I'm going to get 3 over 12. And if I double up 1 over 6, I'm going to get 2 over 12. So adding those two together then, I'm going to get 5 over 12. Okay, so the probability of win is 5 out of 12. So remember the question is Anna more likely to win or lose? Well, the probability that she loses is 1 minus the probability that she wins, isn't it? So that's going to be 1 minus 5 over 12, which is 7 over 12. Okay, so probability that she loses is greater than the probability then that she wins. Okay, just need to be careful in these sort of questions that you've actually stated what it is that they want you to do. Is she more likely to win or lose? So we've said more likely. Let's put it in words as well. Then come more likely to lose. Sorry. Okay. 3 friends arrive at a party. Their arrival increases the number of people at the party by 20%. In total, how many people are now at the party? Okay. Now, percentage questions like this I normally do with a triangle, final, original multiplier, and then I work out what I've got. Have I got the final? Have I got the original? Have I got the multiplier? Final is the value at the end. Original is the value at the beginning, and multiplier is the decimal version of the percentage that's been applied. Okay, so now this is a percentage increase. Okay, so the number at the party is going up by 20%. So 100% plus 20% is 120%, which is a multiplier of 1.2. Now, the original number of people at the party we don't know, actually. Let's call that X. And then the final number of the people at the party is going to be our original people at the party plus the 3 that arrived. So I'm going to get X and X plus 3 people at the party afterwards. So in total, how many people are there now at the party? I can use that to form an equation in X because I can say that my final percentage is equal to my original times my multiplier. Okay, so my final I decided was X plus 3, and my original was X, and my multiplier is 1.2. So I've got X plus 3 is equal to 1.2x, and haven't I? Okay. Now what can I do? So taking X away from both sides, I'm going to get 3 is equal to 0.2x. So then if I want X, I'm going to have to multiply both sides by 5 then, aren't I? Times by 5 times by 5. So I'm going to get X is equal to 15. So there were 15 people at the party, 3 people joined, making 18, and that is an increase of 20%. So if X is 15, then F final must be 15 plus 3, which is 18 then, isn't it? And that is the answer we're looking for. We're looking for the, in total, how many people are now at the party. So we want that F value. So the answer is 18 people. Work out the value of 3 to the power 12 divided by 3 to the power 5, all divided by 3 to the power 2 times 3. Okay. Now I'm going to do the bits in the brackets here to start with, because brackets come first. So let's do that bit and that bit first, and then we'll work out what we've got after. So inside the brackets, 3 to the power 12 divided by 3 to the power 5. So I've got two numbers with the same base that I'm dividing, so I subtract the indices. So 12 subtract 5 is going to be 7. So that's 3 to the power 7 divided by the second bracket, 3 squared times 3. Two numbers with the same base that I'm multiplying, so I'm going to add the indices. 3 to the 2 times 3 to the 1 is going to be 3 to the 2 plus 1. It's 3 to the 3. Okay. Again, I've still got two numbers with the same base. I'm dividing this time, so I'm going to subtract the indices. 3 to the 7 divided by 3 to the 3 is going to be 3 to the power of 7. Subtract 3, which is 3 to the power 4. Okay, 3 to the power 4. Do we have to actually work out the value? What is 3 to the power 4? That's 3 times 3 times 3 times 3, which is 3, 9, 27. 3 lots of 27 is 81. Okay, so my answer is 81. Okay, done. 24a. We're given that a plus b is equal to 0. Which of these is equal to b? Circle your answer. Okay, what have I got? A plus b equals 0. If I want to get b by itself, then I'm going to have to subtract a from both sides, aren't I? So that a, subtract that a, they'll cancel out, leave me with b on the left hand side, and 0 minus a is just minus a. So b is equal to minus a, which is that one there. Okay, and part b it says c times d is equal to 1. Which of these is equal to d? So again, if I write down c times d is equal to 1, now if I want to get d by itself, I'm going to have to divide both sides by c, which I'm just going to write like this, I think. Divide by c, divide by c. You can see that that c and that c will cancel each other out, and it will just leave you with d on the left hand side. On the right hand side we're going to have 1 divided by c, or 1 over c. Which is that one there? Okay, so it's 1 over c. A shaded semicircle is inside a circle as shown. The radius of the circle is 10 centimeters and the diameter of the semicircle is 8 centimeters. How many times bigger is the unshaded area than the shaded area? Okay, so let's work out the shaded area first. Shaded. Okay, that's this bit here, isn't it? Now, the area of a circle is pi r squared. So a semicircle is going to be pi r squared over 2 then, isn't it? Okay, so in this case, r is half of d, the radius is half the diameter. So it's 4 squared, 16, divided by 2, 8. That's going to give you 8 pi. Now let's have a think about the unshaded area. Now it is a circle, so it's going to be pi r squared, where this time the radius is going to be 10. So r squared, 10 squared is 100. So that's 100 pi. But remember, the unshaded area is going to have the shaded area cut out of it then, isn't it? We want the area of the unshaded part, not the area of the circle. So we need to take off that pi r squared over 2 that we had earlier. In other words, we need to take out the 8 pi. And 100 pi take away 8 pi is 92 pi. Okay? So the unshaded area is going to be 92 pi and the shaded area is going to be 8 pi. How many times bigger? Number of times bigger is going to be the bigger one, 92 pi, divided by the smaller one, 82 pi. Now I left it in terms of pi because I can then just cancel those out. That pi cancels with that one, and then I just need to divide 8 by 92. Okay, so 8s into 80 go 10 times, so 11 8s are 88, so it's 11, remainder 4, 11 and 4 eighths, which is 11.5, isn't it, 11 and a half. Okay, so it is 11 and a half times bigger. Done. The number of items n made in 1 hour by a machine is given by n equals 60 over t, where t is the time in minutes a machine takes to make one item, and the value of t changes for different types of item. On the grid below, draw the graph of n equals 60 over t for the values of t from 1 to 4. Okay, so let's just do a quick table of values then. For t equals 1, 2, 3, and 4, and the corresponding values of n. Okay, now note that t can't be 0 because then you'll have division by 0, which is a bit of a no-no. So let's start with t is equal to 1, n is equal to 60 divided by t. 60 divided by t is 60. If n is 2, then 60 divided by 2 is 30. We're halving each time, aren't we? So n is 3, n 60 divided by 3 is 20, and n is 4. 60 divided by 4 is 15. Okay, so then my points I'm going to plot. So at time 1, t is equal to 60. At time 2, t is equal to 30. At time 3, t is equal to 20. And at time 4, t is equal to 15. Okay, so I'm going to, what am I going to do with that? Am I going to join it up with a curve? On the grid below, draw a graph, so I suppose I do have to join them up with a curve. Okay, so it's going to be one of those graphs. It's a little bit like 1 over n, isn't it? It's going to be like the right-hand part of 1 over n. So my line is going to come down from infinity through those points, like that. I think I missed that first point. Let's try that again. So my line is going to come down from infinity through that point, through that point, through that point, through that point. Okay, so your axes are asymptotes here, aren't they? Okay, right, so part B says the machine takes 3 minutes 30 seconds to make one item. Use your graph to estimate the value of n. So 3 minutes 30, is halfway between 3 and 4. Let's get the ruler out. Oops, draw a line up from 3.5, which is going to be halfway between 3 and 4 to the line. Okay, and when we get to the line, I'm going to change direction. And we're going to go that way until we get to the y-axis. Okay. What's that value there then? Okay, counting little squares between 0 and 10. I've got 1, 2, 3, 4, 5 of those. So they must be going up in twos. 2, 4, 6, 8, 10. So that one there has got to be 10, 12, 14, 16, isn't it? So I'm going to estimate that the number of items is 16. N equals 16. Just wanted to take a few seconds out to talk about my Patreon page, which you can find at patreon.com/Mr. Tompkins EdTech. On here you can gain access to exclusive content, including early access to my past paper walkthroughs. So if you like my content, definitely worth checking that out. Also, if you become a Pythagorean patron, you get a special shout out in every video. So check it out. Back to the maths. Question 27. Rearrange x equals 2y minus 6 to make y the subject. Okay, so I've given this. You can do this pretty similar to how you would solve an equation, just trying to get y by itself basically. So we can start by adding 6 to both sides. That bit will cancel with that, leaving you with 2y on the right, and then x plus 6 on the left. And then we're going to divide both sides by 2. Okay. So then that cancels with that, leaving me with just y. Y is equal to x plus 6. I'm just going to leave it like that, x plus 6 all over 2. Okay, that's my answer. Y equals x plus 6 over 2. Okay, and 28, multiply out and simplify x plus 5 times x minus 1. Okay, now there are different ways of doing this. Some people do it using FOIL, first, outside, inside, last. Some people remember it as 2 eyebrows, a nose, and a mouth. You can also do it by a kind of a grid method, which is what I'm going to do here. Okay, so I've got an x plus 5 in that direction, and I've got an x and a minus 1 down here. And then I'm going to work out what I'm going to get when I multiply all those things together. So x times x is x squared. X times 5 is 5x. X times minus 1 is minus x. And 5 times minus 1 is minus 5. So then I've got 3 terms. I've got a term in x squared, which I'm going to write down first. And then I've got 2 terms in x. I've got a minus x and 5x, which together, 5x take away x is 4x, so plus 4x. And then finally, I've got a minus 5 on the end. So I'm going to get minus 5. Okay, so x squared plus 4x minus 5. I think we're done. So that's all. We've reached the end of the paper. How did you do? Let me know in the comments below, along with any questions you still might have. Don't forget to like and subscribe if you found this walkthrough helpful. If you didn't do so well, try revising around the topics you're struggling with before attempting another past paper. Good luck with your preparations and in your exams, and see you again next time.